Okay, this is the video for graphing inequalities. So we know that if we have A is less than B, so then what we have is then we're looking at something like this. So here's B, and A is over here. So A is over in this region. And if we have or, it could be here. Or if we have A is greater than B, then here's B, and A could be over here. Now, when we're talking about lines, then we have that a line is equal to. So if it's equal to, then we have a solid line. So when we graph a line, I'm trying to see where I talk about this. And I don't necessarily say. All right, so when you sketch your line, if it's equal to, you're going to have a solid line. So if it's equal to, then solid line. If it's not equal to, then you're going to have a dashed line. All right, and I think most of what we have is equal to. When you're testing a point, to test an inequality, you're going to use 0, 1. If your line goes through the point 0, 1, then you're through 0, 0, then you're going to test something like 1, 0, or 0, 1. And that'll make a little more sense when we get to an example. So let's look at our first example. So what you're going to do is you want to graph this line as though it were the line, let's solve for y, minus 4x plus 10. So you want to graph the line y equals 4x plus 10. So we know that we have the y-intercept 0, 10. Because this point is the point 0b is our y-intercept. All right, then you need to find a second point that is on this line. So we're going to let x equals 1. Then we have y equals minus 4 times 1 plus 10. So y equals 6. So then we have the point 1, 6. So that gives us 2 points to graph that would exist on this line. So we have the point, so we have the line 0, 10, that's 1 point, and then we have 1, 6. So here's x, here's y, and this is the line y equals minus 4x plus 10. Now, we did a solid line because we have an equal to. Now, we want to test 0, 0. So if I put 0 into my inequality, so 4 times 0 plus 0 is less than or equal to 10, I get 0 is less than or equal to 10. Is that a true statement? Yes, it is. So this is true. So that means that this point right here lies within the region, so everything less than this line satisfies that inequality. So that means that this is the area that I would shade. So from now on, what we're doing is we're shading regions. So this is not just a line, this is a region. Okay? And this is also an unbounded region. Okay? So let's look at number 2. This is the line x equals 1, but I want everything that's greater than x equals 1. So that would be this region. And again, that's an unbounded region. Okay. Sorry. So now I have 2 lines, and what I want to do is I want to find where these 2 lines intersect, and I want to find each of these lines separately. So one way to do this is to find the intersection. So I need to find the intersection of these 2 lines. So if I want to look at the intersection of these 2 lines, so what that means is if I multiply this top line by 2, then I get 6x minus 2y equals 18. And I have x plus 2y equals 3. And then I add the 2 lines together, then I have 7y equals 21. So y equals, divide by 7, so y equals 3. So now if I know that y equals 3, and I put that answer into the first line, so I have 3x minus 3y, not 3y, just 3, equals 9, so I get 3x equals 12, so I get x equals 4. So that tells me that their intersection is at the point 4, 3. Okay. Now, if I let x equals 0 in the first line, so if x is 0, then I get y is negative 9. If I let x equals 0 in the second line, then I get 2/3, then I get 3/2, sorry. So if I graph these lines, then I have negative 9, I have 0, negative 9, and then for this one I have that, where this point right here is 4, 3, this point right here is 0, 3/2, this line right here is x plus 2y, and this is 3x minus y equals 9. Now, how do I know where to shade? So I'm going to test 0, 0. So if I put 0, 3 times 0 minus 0, is that less than or equal to 9? Yes. So that means that for this line, everything goes towards 0, 0. If I do it into the second line, 0, so everything goes this way. So where I'm going is this way. Can I assume that it's just this region? So can I assume that it's just this region? No, because, yikes, didn't want to do that. I cannot assume that because I don't have any bounds that tell me that I'm greater than 0 for x and greater than 0 for y. So it also includes this negative portion out here. So make sure that you're looking at all your restrictions. Okay, you can't just assume that I'm only in the positive values. Okay, so now for this example, I can assume that I just have the positive values. So let's look at this one. So if I have, so here I have 0 for x, then I have 1y. If I have 0 for y, so imagine putting your finger over the x. So for the first one, if I have 0 for x, then this goes away. So then I have 4y equals 4, so y equals 1. All right? Great, I can erase. Huh? If I have 0 for y, then I have x is 2. Then I can erase this one and go back to that one. So for the second one, if I have 0 for x, so that goes away, then I have negative 1. Erase. If I have 0 for y, then I have 1. Okay, so that gets me to graphing my lines, right? So I'm going to go over here. If I put my pencil back, and I'm only looking at, yikes. So I'm looking right here. So here's x, here's y. So I have this one, and I have this one. So this is the point 1, 0, and this is the point 0, negative 1. So this is the line 4x minus 4y equals 4. This is the point 2, 0, and this is the point 0, 1, and this line is 2x plus 4y equals 4. So now I need to find this point right here. All right, so what I'm going to do is I'm going to change that. So this is the point I'm trying to find now. All right, so how do I do that? So what I'm going to do is I'm going to say 2x plus 4y equals 4. 4x minus 4y equals 4. And I'm going to add these two. So 6x equals 8. So x equals 8 6. So that's 4/3. Right? So if x equals 4/3, then I have that 2 times 4/3 plus 4y equals 4. So that's 8/3 plus 4y equals 12/3. Subtract 8/3. So 4y equals 4/3. Divide both sides by 4, so y equals 1/3. So so this point right here is the point 4/3 1/3. Okay, now I need to test. And I'm going to test 0, 0. So I have 0 plus 0 is greater than 4. And that's a no. So that means that in this line, everything goes away from 0, 0. Okay, and here I have 0 minus 0 is less than or equal to 4, so that means yes. So in this line, everything goes towards 0, 0. All right, so my answer is going to be this region right here, but, hold on, I want to erase this. But I also have the fact that I'm greater than 0. So I also have this going into the play, that I'm going greater than 0 because x is greater than 0. So I'm really only in this little part right here. Okay, so I'm really only in take the pink. Right here. So I'm stopped right here at the X, at the Y-axis. Okay? Now, for this example, you're going to use your calculator. Now, in order to use your calculator, you have to solve for y. Now, here's the other thing. If you use your calculator on the test, you have to draw your graph on your paper. And you have to tell me your intersection on your paper. All right? So, in order to use your calculator, you have to solve for y. So that's going to be 0.3y equals minus 0.2x plus 7.8. So then you have y equals negative 0.7x plus 26 for the top one. And that would actually not be equal, but it's a greater than equal. That sign is important. And for this one, you get minus 6.7y is less than or equal to negative 2.5x. So then y, now because this is a negative sign, you're going to flip your inequality sign. So that becomes 0.4x. And I went ahead and wrote the plus 0, but you don't have to. Now, to put this into your calculator, what you're going to do, sorry, I thought I was grabbing the thing. To put this in your calculator, you're going to hit y equals x. You're going to type your equation in there, so that's going to be negative 0.7x plus 26. That's going to be in your first. Then here you're going to have 0.4x. Then you're going to graph, and it's not doing what I need it to. Okay. See, I'm trying to get it into Z standard. Okay, there it is. If I zoom out, it'll do it. All right. Sorry, I haven't played with this on this one. So, calculate. So, this is enough different from my calculator that I'm... Okay, there is a way on your calculator, and I say this in the scan notes, of how to find the intersection point and how to find the... to graph. And so I'm going to see if I can get it to graph. So if I go over and it may not do it here. Okay, so this is a little different. So I want it to be this one to be greater than or equal to. I want this one to be less than or equal to. And so now let's see. And so it's telling me that my intersection region is here, which is wrong because it should be up here. No, I had it graphed wrong. There. Now, it will not, I don't know that it will graph x is greater than 0. Okay, so on this one you can hit the buttons down here if you're using this one. I don't know if it will graph x is greater than 0, but if you go back to the graph, there's the graph. On the normal calculator, within the graphing utility, you can find a way to, there is a way, and I say this on the notes, and I show you, and I tell you the keystrokes of how to find the intersection point. And so I'm just not seeing it here. And there may be a way within here that I'm just not seeing. So, but for this particular question for 5 with these numbers, I would expect you to go from your calculator, show me the picture, and then show me the region. Oh, this one doesn't have. So from your calculator here. So this is y. And then show me that this is y equals 0.4x. This is the line y equals negative 0.7x plus 26. You would find this value on your calculator, which on my TI-84, I found that this is 23.6, 9.5. And that's what you would need to show me. All right. Now, I'm going to stop this video on this example and then do the next couple of videos as their own examples because of their word problems. All right. So if you have any comments or questions up to this point, please email me and let me know. Thanks.